Uh, Welcome to today's live stream. And today we are going to explore uh, some good things. For example, we're going to do some coding and um, debugging for those who are familiar with what we talked about last or the era we got last stream. We will be doing some debugging on that as well. So first of all, let me just give you an overview of what we talked about last stream, what we did and what we went through. And let me get something ready here. So, all right, so in the last stream we did a few walk through the parameters of the system, what the system's parameters are, and how those parameters are used in the whole system. We talked about um, the the actual parameters that we measure, and that tells us information about what the system does and how the system is behaving. And then we also talked about okay. We also talked about hyperparameters. The hyperparameters are those that are controlled. They help control the system, keep it in its equilibrium state. So those are those are what we use for the genome, the best genome that we get through evolution, and then we use those parameters through the meta-tuner. So the meta-tuner also uses these parameters to. All right, sorry about that. Give me a second. Yeah, so the meta-tuner also uses these parameters to do some tuning whenever the system hits a threshold or goes below a value that would potentially lead to a system meltdown or something like that. And then we went through some data. We went through the graphs, how the graphs represent what they represent and how they look like when, or how do you compare two graphs or two parameters together to see the performance of the system. And we also found we ran another simulation another training, essentially just simulating some the parameters and see how they play around. And then we got these results. So these results just represent what we did, what the run does, and how the bug that we talked about shows at what point and at what point in time of the training. And what we want to explore today, hopefully, is try to figure out why this is happening. Like how comes at a certain point of training, a certain point in our training, we hit this meltdown in the system. So the system hits a meltdown and then goes directly to zero. Coherence reads zero, and then it keeps that bouncing back and forth at that range between 0 and 0.88. So that's what we want to explore, and that's what we want to be debugging throughout this stream. So let me get stuff uh, ready. Okay. All right. Okay. So we will do some debugging. So I showed the code. I showed how the code is structured, and what we want to do now is figure out. Let me get these two. we want to figure out at this point in time. So we know the point where it fails. It starts to misbehave. And oh, one other thing is this happens when we use the configuration for Richard. Let me just open that. So we have a few configuration and the one for Richer actor. So we have a Richer environment and then we have an actor for that environment. So once we turn these on, we use the same configuration. We have autopilot on. And remember, autopilot doesn't mean that the system runs on autopilot. It just means that the system um, adapts throughout the system, throughout the training process. Just the learning process is adaptive. And so, okay, so what I want to show is so we have the same configurations. A few knobs a few plugs are turned on and off. So the environment name is Richer. And let me just show the example toy version of this. So I'll just do like a 5B. 5B is just the previous run before we hit the one that uh, shows the error. So 5B has pretty much the same configuration. Let me just check that. Look, we have same stuff. Autopilot is on, and then chaos, genome, probably the same. And then so the only change here is the environment. So the environment, uh, we have Richa, which fails, and then we have the toy version. The toy version is what is what is succeeding at the moment, and we don't want to focus on the toy version because it works on the toy version. But when we run the model or train the model in an environment that is more complex, like richer, then we get these phenomena we found right here. So at some point in time, the system just melts down and then goes to zero, coherence misbehaves, and some other parameters as well. Some other parameters does the same. And what we also want to do is look at how Storm. Okay, Storm is also very high at the same point. So Storm gain was at that's it's actually the same. Is it the same? No, I don't think it's the same. But sometime throughout the training, Storm is just up there. And okay, and I'm looking for chaos. Don't we have? Okay, we do have chaos. So chaos is also is doing well at the same it's just dancing around point 2 and point 6, and then it hits at this same spot where we got the I don't know what's happening though, but that's what we want to figure out. But at this point, it just goes up and stays there. And when we run these for very many steps, we get the same thing, same behavior. Chaos is stuck up there. It never goes. It never tries to go back to its state. So we want to figure out what's happening right there. And then something also happened with so this is the surprise accumulation, how much surprise the system gets. So we also get, I don't know if this is the same 2780. No, it's not the same, but something happens there. Surprise system gets surprise a lot here. So yeah, let's try this. So we want to figure out what's happening. And let's keep note of what's the step that fails. I mean the number of step that the system hits and then goes to zero. So that's like 2780. We can try to do small training, but let me see if we can do that. So first of all, let's go to where this is happening. So this is coherent. So okay, so the tricky part is we don't know what's causing this, and debugging will be very hard. And what we just want to do is go through each step and see which parameters causes the other. So first of all, each parameter might lead to like some parameters changed before like coherent hits goes to zero. Let me close some things here. So that parameter, we want to do some debugging and find out what's happening. So let me start with let's start with what? Coherent mean, equilibrium, or I don't know, coherent. So let's start with coherent. Coherent is the function. So kind of. Okay, I think coherence movement degenerates. Yeah, so in homestat, we have this function called coherence. And at this point, we can do some PDB, traditional PDB. You can use other PDB like so just go traditional debugging, and we can go to homestat as well. Okay, wait. So this is focus coherent. So what we're looking at here is this is coherent, realized coherent, and then focus coherent is this. So this is what so realized is this. We already have PDB right there. And then focused, it's happening at the same time. Same time, we also go to zero. Is it the same? Let me see. 2740, 2720. It's not bad. Okay, so we will do maybe the first PDB, then the second PDB. And yeah, manual debugging is a headache. But anyways, let's see. So we have PDB set on coherent. We need also, okay, let's not do much, a lot of PDB because we get lost. But let's check one other thing that might might be causing this. So we get equilibrium coherent mean. So where is this in the equilibrium class? Okay, so we have stats, coherent mean. So this is calculated. Yeah, mean self. Okay, it's never null, not a number. So it's just a number. So we might just want to go. Okay, does it go to zero? It goes to zero. Yeah. Okay. We want to know which one comes first, which one does fail first. So this is going to, funny thing is just, oh, it's the mean. Just drops, keeps going. So it starts from 2660, keeps dropping, dropping. Initially, it was just doing well until it hit. So wait a minute. So this is here. Oh, I see. So coherent mean starts to drop before coherence. Okay, so this is 2720, and then this is at this point we are at 2700. So 2700 is okay. So okay, what does coherent mean affect this equilibrium? Okay. Oh, so the mean takes in coherence or all of them. Not this. This is update state, so it updates this coherent mean, takes in coherent values. Coherent values is just the coherent. This is realized. Guessing yes. So this is realized coherent. Okay, D for data in. Okay, I think something is wrong. Yeah, adaptive state buffer. Okay, let's run this and then as we read it. So we will do which step, smallest step possible. We will do run form. Let's do it for, how many is this? 5,000. So let's do it for, I don't know, 5,000. 5,000 steps. And okay, let's do configuration. Okay, the default. We want this. Okay. Is it the same? Okay, let me try this first. 29, 29, 29. Do we have 29? Yes, 29. Okay, so 29 starts from. Okay, it's just same. So neither this starts earlier. Okay, let's use 29. So I will run with this configuration. So this is only changing to richer, and version 5. Environment is richer. Chaos is on. Chaos is false here. Okay. This is 0.95. And this is same. Oh, no, actually, this is 0.9. And what else? Meta tuner is also on. Let's see what precision looks like. Precision is 0.1 point. It starts from 1, and this one starts from 1. Minimum is 0.6. Maximum 0.35, 3.5. Fine. Pi up is okay. Not. It's the same. Okay. What about this? It's a price threshold. Same. Okay. Okay, we want as the minimum version of this configuration. And what we can do is just turn off all the, how about these plugins? All the plugins, we turn them off. For example, we turn these off. It's already off. For this case is turn off this. Oh, so this is on. We will turn this off first. We will turn this off. And this is off. This is regime is on. Okay. This one should be off as well. We want to try a minimum version, a minimum config to remove all the other noise. That will give us, it will narrow the search. And this is all of what else? What other plugin? Spectral. Okay, let's see why spectral. It should also be off. Actually, let me copy this so that I don't. Oh, okay, let me copy this config. And what's the name of this guy? Let's call this 7A minimum. And open that. Okay. So we want the plugins off. Plugins off, all of them is off. Okay. And this regime should off. Spectral. Okay. Next. I don't know what happens if we get the actor off. Turn off actor. Is it the environment or is it the actor? So let's try with just the environment richer, and then actor should be off. We can try one other thing. Chaos, 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 chaos. Chaos is off. Okay, good. We good. So let's try to run this, and we know where. Okay, where did we put our PDB? PDB was here. No, wait, what? Kernel. Yes, kernel. PDB. Use pretty print. There was another one. I don't know which one it was. So we have one in health. Okay. So health. Okay. Okay. So we trained this for 5,000 steps. Should be fast. Hopefully. So this phase 7. Phase what? Okay. It's not working. No way. We have a syntax error. Training line 59. That's not good. Wait, which Python version is this? Are you serious? Oh, I see the problem. I need to source from my this environment. Okay, hopefully we have the right version. Okay, good. Ah, okay, it's no way. That was fast. Yeah, we can't we don't need to do this every step. We need it to be exactly at 2000 steps and above. So let's try. If serve dot time is greater than 2000, then we can do this. We can debug this guy. Do we have system here? System, yep, system. Okay, quit. We want to start again. Oh, no way. I overrode. Damn it. Okay, I overrode 29. That's not good. No, just delete 29. Okay, 29, 29, 29. See if we still have it. Oh, okay. Don't delete about. So we make this 31. Okay, we make this 31 and let's try again. So I'm logging every 20 steps. Hopefully this runs fast, but maybe uh no, let's use CPU run because of it's taking slowly. Maybe just no device. Okay. Okay, let's pretend that we get somewhere here and set this to CPU. Don't want to. Because it's just a few steps. It's just a few thousand steps, so we don't need to be doing this on GPU. Okay, let's try 31. Delete this. No way, it's even slower. Still MPS, but are we still? No, I don't think we are. We're still running on MPS, but okay. I guess there's some other code that's running before this. Okay, I see. It's from my environment config. We don't have time to wait for this guy to finish 5,000 steps. Yeah, that's good. So let's do. Okay, so hopefully we hit the PDB. Okay, well this runs, it's PDB. What else? What else config? We want another parameter that might affect uh, the system. Maybe chaos is independent from what the system is doing. Like chaos, it's on its own. It's the diagnostic of the system, so we can't really use chaos to debug. What we can do, okay, energy is still okay. Energy doesn't. There's no there's no strange weird stuff happening on over energy. Only at this step where energy just hit to a very maximum value, it overshoots. But what we want to not see is weird behavior. So this is running normally. Delta H is running okay, and maybe surprise, but surprise. Wait a minute, surprise. It's around the same time. So I think when when coherent hits goes equilibrium coherent mean goes to minimal, starts to drop down. It starts at the very step where surprise accumulation goes up. So I think one other thing is find out what surprise accumulation is doing, where it is, and debug that. And what we can do is awesome. So it's done. So this is what we want to find out. Coherent, is it zero? This is which step? This is in the kernel. Kernel is coherent realized. Okay, is it zero at this step? No, it's still above. So we need to go to another to continue. Maybe continue system self dot t is 20, no. So at 2001 still okay. Let's try continue. 2000 and this is in health. What is the step? Time is 2001. Let's keep going. 2000 and time is 2001. Okay, now we are at self.time 2002. What is coherent realized? It's still doing okay, so we need to go to a few steps for ahead. I don't know. We can do it step by step so we catch that bug. Precision still the same one. Coherent here is same. Okay, in the health we do have health. We have what did we want to know? We wanted to know what coherence is. So this is focused coherent, and we need to also do that. So focused is that. So focus is one. Is it one step or two steps? Focus is just we go x next. I think it's t plus one, which is one step. And let's see. So focus is on 0.98, and then realize is 0.997. So we keep going. And this is time. Time is point. Wait, 2004. We skipped 2003 somewhere. Okay, hopefully we're still okay. So let's find out what coherent at this point is. Still doing okay, so we have no problem there. Let's keep going to health and see what this is. Okay. Uh, nope. Okay, so I don't think we have realized coherence in health, but focused is the focus. So this was realized at the current step. Then the focused is the next step. Yeah, it's dropping for some reason, but we're still in 90%, so we're not scared at now. At this point, we're still doing okay. So let's go to next step. And this is time. Let's find time. Time is 2005, and we want to know what coherent is. Still doing okay. And I'm curious about what realize focus coherent looks like here. And it's not bad. It's off by 0.0101. Yeah. Okay, let's keep going. Next step, time. Okay, shouldn't be. Oh, this is not okay. We're in this in the wrong system. This one is system.time. 6. Okay, weird. Which one was this? And self.time. No. Self.time. System.time. Okay. Continue. Self.time. 7. How? How did you get 7? Oh, I see. Skip this. Okay. So what is coherent? Still doing okay. And here. Oh, focused goes to 85. That's bad. 0.85. I think that's not good. 0.85. Let's print these first. 31. This is the one that we are currently working on. So we see here we are at 2000 and around 2000. We're still in 2020. When we get to 2020, we will see a change here. So because the logs are in what margin of 20. So let's do at what point is this? So this is 0.85. That is forecast, and realized is 0.99. Okay, let's go. Let's keep going. And this time t 8. 2008. What is coherent? Okay, still okay. What is focused? Coherent? 0.8569. This is 0.8538. Okay, we're still okay. We haven't hit the 0 mark. Let's keep going. Which one is this? P. Okay, so this is a self.t, and coherent is still okay. Coherent for, yeah, it's, wait, so it looks like forecast coherent is dropping every time. Every time it's okay, we can't see the log. Every time it just keeps dropping. Maybe if we did log, okay, let's just keep going and find fast, and then we can do the logs in say log it by what, by instead of 20 as the margin, we can keep logging it for like each step, so we can see the figures how they behave. But since we're already in between the debugger, let's just keep going. So this is wait, oh, okay, so I think I missed a step. Okay, this is this thing not dropping. Okay, in the kernel coherent realized 9. Realize is it's okay, it's fine until focused is okay now. I think it just keeps playing around. Okay, let's go on. What is time? 13. And coherent, damn it, okay. Coherent this is forecast coherent 0.9. Let's see, keep going. And time at, okay, that's a lot. Okay, time 2014, and then we do, oh, I skipped again. What is focused? I can do previous first. I can't do previous. Come on, PDB. You can't do previous. PDB previous previous. Is it breakpoint or command? Previous command. PDB. You have n as next. This is stupid. Let's just keep going with the Control P. Anyway, let's just keep going. Continue. Coherent. Coherent is fine. Focus coherent is okay. And going. I skipped again. Okay, I should be slow. We need to capture the 0 mark. Step system.t 15 system self.t. T is in the kernel system. So 2016 and coherent, realized coherent is okay. Focused is also okay. And self.t 2017. We're almost hitting the debug step. And the coherent is coherent, realized coherent. Okay. I don't think we need to check this. Let's see. Okay, it's fine. And self.t. Okay, I should stop doing self.t. Actually, I should see what time is because we want to see that specific time that the system breaks. And coherent, realized 9. And that's interesting. Okay, let's keep going. Self.t and coherent. Self coherent. Okay. Coherent. There you are. It's dropped. Okay, self. Oh my God. What did I do now? So at step 20, this is what step 20, what is time? 21. 21. We didn't hit the 0 mark though. At 21, we got to, okay, we have not hit the 0. Skip, let's see what coherent realized is. Focused is. Focused is 0.9. Okay, so it's still okay. And self.t. Okay, I think we're still not hitting that. Maybe it's where is it? It's here. 2000. Okay, this is different. This is going to zero at 2020, 40 or 20. Okay, this is weird. I think it's different. Oh, I see. Okay, so the seed, no way, the seed is the same value, so I don't think that's the problem. 31. Because we are at 20, 20. Okay, 20. You know what? Let's see. Let's do the logs at let's log every one step so we see what's clearly what's happening because I think we can do this manually. We don't have time to do this manually, but let's see what we can find out using slugs. Okay, log in every step. Is it every step? No, it's logging. No, it's still logging every step. I have 20 step. Ah, okay. It's okay. It's fine. So this goes to 0.5 and what is time? 1. All right. All right. So I think it's PDB using visualization is much easier than PDB. So we can do we can do PDB as well because we need to track each parameter at that specific spot. So we can uh, continue to, okay, this is bad debugging technique. But we want to get to 20, 21, 22 here. Set that time, 27. Oh, okay. Save dot time. Okay, let me just assign time a value, say 20,000 and 2000 dot 2001 because we stopped at 2001 and continue. What is time? System dot time. Okay, we're good. So what is coherent? Okay, next. Self dot time 22. Coherent realized 88. So here something happened. So it went to 88.9. Oh, we still haven't logged that, so hmm, 0, 0. I want 0. I want 0, 0. Okay, I don't want to see 90. Okay, still 99. And no way. Current. Let's see. 0.89, 0.88. We haven't hit the 0 mark. We're still here. Still doing okay. Doing okay. Doing okay. 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 Something happened. No. Everything looks okay. Pi is going crazy. I think that's why. That's because we're doing. We are logging at every step, one step at a time. But still, I don't know. It's behaving weirdly, strangely. What's this? Goes to zigzag, zigzag. Anyways, so let's keep going. Trying to find a 0. If we see 9.9, we are still doing good. Anything above point 0.5, we're good. This is a lot. 0.9, 0.9, 0.9. 0.9. Okay. 0.9. 0.9. Oh, yeah, still 9. Still 9. 0.9. Okay, where are we? This is 5.2. .9. So okay. 0.9, still okay. 0.9, still okay. 0.9, 0.8, still okay. 0.9, still okay. 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 9.3. Okay, I think it dropped a bit. 9.3, what happens? The mean is still fine. Okay. Okay. 9.9 is fine. 0.9 is fine. 0.8. 0.9. Come on, come on. We're looking for 0.9 still okay. 0.9 still okay. 0.94 still okay. 0.8 fine. 0.9 fine. 0.9 fine. 0.9. Oh shit. Okay, okay, okay. Let's see. Maybe you can do this by code. I think manually it's just crazy, man. Crazy time. And coherent is equals to 0.0. We can do PDB right there. Do the same for what? For kernel. And we have realize coherent is equal to. Oh, this is not JavaScript. Let's make sure we don't write JavaScript here. Equals to. uh, Oh my God, I did waste a lot of time just doing deep manual PDB. Jesus Christ. Let's try again. Um, Hopefully there is no zero in between one and 1,000, 1 and 2,000 and 150 something there. So we can delete this again and we can try this approach. Anyway, we've learned you just do coding anyways. You can't do manual work because it takes so much time, a lot of time. Do that with code. Okay, we good. We are there. So we can do. Okay, we got a zero. So what step is this? Self dot. No, it's a system dot time. We got a zero at 29:79. Are you serious? We would have gotten that far, quickly. Z, I don't think so. Okay, 29:75, 79. So this is coherent, is realized coherence is zero. And what is focused coherent? Can I find out what focused coherent is? Because if, oh, I see. This is focused coherent. So focused coherent is zero, which means the focused version gets to zero first. So we can know when the system will break down just by looking at focused coherent and what happened at focused coherent. I see. So this is I see. We've been looking at the wrong one. So I think the issue might be with focused coherent. I mean, focused coherent will tell us what next step will look like. So next step will fail at step 7, 2970, 980, the system will fail. So we know that, right? So what we can do now is figure out why focus coherent is zero. So that's in health. Uh, okay, focus coherent is zero right here. So what is X? So X next is so it's a metric. So what? It's a tensor. And what is Y next? So Y next. So from this, we compute what focus coherent will be. And that's a problem, right? So we can't really figure out. Let's go to this. We get in the first x and y tensor, dimension normalized northern sensitivity as tensor. What we get in return is zero. I wonder why it's zero. So mean squared error. Oh shit. We need to also do something like PDB, PDB, search trace. Okay. But this is a tensor. And this also. Size. And okay, I don't think I do tensor. Dimensions. Okay, yeah, it's just size. 28. Okay, 128. Oh yeah, so this is the state. So we have the state 128 as the observation state, observed state, which is 128, and then the next prediction will be 128. Oh, same size. because it's a prediction of the okay the observed state. So we get this returns minus, which means the mean squared error might be zero. Early zero saturation avoids early zero saturation, keeps the range within within 0 and 1. But we got a 0.0, so let's see what this is. Residual, okay, R tensor, as tensor type is float 32-bit floats. Yeah, we're using 32 as float, so float 32, which will be in a device, somewhere. Yeah, so 32. Let's see what mean squared is, because I don't think we can print it. We can debug it. We can do it directly from coherent, because that's where coherent returns 0, which means, oh, okay, forecast coherent returns 0, which means either mean squared error is off, something affects it, and run again. And what? No, 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 I can't do that. I need to have this function here, but also need to make sure I have system inside system. And right, and coherent zeros. But wait, we can't do that. So if this is 0, we can do this. Let me do if this is 0, let me say this is coherent. Shit, I can't type. Okay. Shit, okay. It's not writing JavaScript. Is this wrong? If system and system t is equals to, it's not defined. Oh, system. Okay. And run again. Let's make sure we clean this up. Okay. Right. So what happened? So progress system system.t. Wait. Oh my God. What? self.t. No way. Hmm? What? Coherent 0. Wait a minute. The previous run gave us coherent. Oh my God, what happened? Did we do something? I don't think so. So each run has a different. Oh my God, each run has a different value, has different values. Let's just find out. I can't go back. Hmm. So previously we had coherent point zero at 20, was it 2979 step? And now we have coherent at 0. The previous one was coherent, realized coherent, no, focused coherent at 0 first. And now we have uh, realized coherent at 0 at which step? Self.t at 2001 step. So we go to the kernel and see. Okay. Um, sorry, wait. Kernel. Kernel. So how did it? Oh, wait. So this is, we have focused and we have realized. So focused coherent is this. Running stale code until the program is rerun. Okay, fine. So realized is 0 first. Coherent is this. This is focused coherent, and then realized coherent. So focus from the previous step. So this is focused from which step was this? This was focused before, so it was focused before we hit these. What if I don't use time? I just use coherent. Will this give us anything interesting? And then I'll go to, oh, okay, so coherent need the system. Yes, so we need the system. Actually, yeah, I think that's why it's failing, because we didn't pass in the system. But still, it shouldn't fail at 2001. Okay, let's try again. Clean this up. Quit. Okay, so this is what this, okay, same step. Coherent, focused. So we're hitting it much earlier than we thought. Okay. I see. Self. System should be self. Just make sure it works. Still can't figure out why we had the last debug told us that 0 happens at 2979 step. Now we are getting at 2001. That's strange. Even if there is randomness in the system, it's still strange because we're using a seed. 1000111. Okay. Not there. Yo, it passed. Okay, I see. I think it was an error in the debug. Oh, great, great. Anyway, we're still getting the same no system.time. Now we're getting a 2447. All right. Okay. So this is in coherent. Nice. That's what we wanted to see. So we go to coherent and see what's happening. And coherent 0. Now mean squared error. We want to also see the tensor. Tensor is x, x and y, same size, hopefully. Make sure it's the same size. Okay, so what is tx? So tx gives us yeah, just it just states tensor. So nothing interesting. Y ty tensor y. Okay, it's just the same, it's no difference. Tx equals to x. Yep. All right. Any division? Y. So this is fine. So R, what is R? So R is x, tx minus ty, the first tensor minus. So we just want to find errors. It's the mean squared error. So the error between the predicted and the predicted y and the actual x, the current x, and then the predicted y. So these are the what you call R, or the error. And mean squared error is just what, yeah, we all know what mean squared error. So we find a dot product of R. Weirdly, what we're finding dot product of R on R, or input and R. Hmm. Um, same size, same dimension. But what we're interested in is the mean squared error. Why is mean squared error? Now that's it. So that's the problem. Oh my God. What? How comes mean squared error is allowed? That's not good. This is bad. These values are terribly bad. Oh my God. Okay, is that where we go to 0? See. Yeah, that's where coherent fails. Okay, now we have a bug. We found a bug. We found the bug. Okay, let's see if we can try to what happens in the next step. So next step, something should happen. This is kind of coherent, coherent. Yeah, that's fine. Coherent zero, coherent hat is predicted coherent is this. Okay, continue. Um, R, R, X, Y. Okay, these values make sense, but these don't make sense. What the hell happened? Oh, I see. So, oh, sorry. This is I'm looking at the wrong thing. This is minus t. Okay, I'm looking at the wrong thing. So tx ty. So tx minus ty we get. Yeah, still they make sense to me, right? But these don't. These values don't. 2000 minus 2000. Okay, so I think we can start from here. We can start from why why this happen, why this happens. And okay, let's see what happened with the plots. No logs. Make sure we have some logs. It's all zeros, man. So what? Not good. Um, yeah, it's just mean square error just blows up because of the error, the bug. But we found the bug, so that's good. We just need to figure out how to fix it. So this is a problem. Okay. Yeah, I think we'll do this next the next stream. We can continue from this step next stream and figure out how to solve this. So apparently the bug is here, but it might be the bug might just be what oh wait a minute. Okay, so tensor the bug might just be from the very beginning where we pass in the y x and y predict. So the actual and the predicted value is calculated based on sorry it uses the actual and predicted value to get the mean squared error and then the dot function too. So okay, so the dot r. Okay, what's this? Yeah, we can from go back to xy and figure out whether something happened that passed in the values to these values to our function, coherent function. Because what we're getting from y predict is this, which means we have to go to what y predict is. So y predict is what the predict function is returning, which is predict with variance. So predict with variance is predictor. Let's go to predictor. So we need to figure out what's happening here. So we can start from here, figure out y predict, previous x, previous x gets to this, and then previous x to previous x. two steps backwards. Okay, great. So we have a bug. We found a bug. Now we solve the bug. But still, I don't understand. So why is it? Oh, I see. Why is it happening in richer environment and not in the toy version? That's one of the questions we can answer in the next stream. And the other question we can answer is why predict has these strange values. Starts first of all, it starts here where we get weird enough, crazy, strange values, and these are okay. This makes sense. This makes sense. This is not okay. This is bad. Okay, maybe I'm missing the point, but we'll see because they're going crazy. Anyway, so that's it for today. Um, we can continue next. Let's see if there's some in chats. Yeah, Sahil Cohen asking whether we are using local GPU or cloud GPU. So I'm using Metal, so it's local, Apple Metal. So MPS, multi-process what? Multi-process service for MacBooks. So if you're on MacBook and using Metal, you can so MPS is what just allows you to run stuff on GPU through your Mac. And yeah, I think we have no more questions, but thank you for watching and see you next time. I think next time will also be a fun one where we just go through these values and see what's happening and why they are looking strange. And I believe if I keep going with this debug, they'll just keep growing, and that's what we want to find. And I'm guessing that's where the bug is. I'm not sure, but we'll find out in the next stream. Thank you for watching, and see you next time. All right.